Starters and alternators are among the most misdiagnosed components on the vehicle. When a starter won't engage or an alternator won't charge, it's easy to replace the part and hope for the best. But if you don't find and fix the real cause of the failure, you're just going to set yourself up for a comeback and a dissatisfied customer. Here are a few tips to help you avoid both. One of the first tests you should make whenever diagnosing a starter or alternator concern, as well as any other electrical concern for that matter, is to test the condition of the battery. All of the electrical components rely on a good, healthy battery to function properly. So if the battery is not up to the task, we have to address that first. A quick way to test the battery is to use a conductance tester like the one shown here. Conductance testers send a low-frequency AC voltage through the battery to measure the amount of usable plate material remaining. This is an accurate test of the battery's condition regardless of the state of charge. And if the battery passes, you can use the majority of these tools to also perform performance tests of both the charging and starting systems. The next step is to perform a visual inspection. Check the obvious first. Look for loose or corroded electrical connections, loose or misaligned or improperly installed components. And did you know that worn serpentine belts are typically found as the ultimate cause of why alternators, brand new, are returned to the parts house as defective? You see, worn belts can slip on the pulleys, and that's going to affect their operation. It's also going to generate a lot of heat in the alternator shaft bearing, and that's going to accelerate its wear. Yeah, you can't tell a serpentine belt is worn or not just by looking at it. You have to use a special tool like one of these belt gauges, typically available at your local jobber at no charge. Another common problem that results in alternator and starting issues is voltage drop somewhere in the circuit. Now, what is voltage drop? Well, for our purposes today, voltage drop is the source of resistance somewhere in the circuit that's not supposed to be there, and it's robbing voltage away from the starter or alternator. Of course, neither can work as they're supposed to if they're not getting the voltage they're supposed to. Now, remember there are two sides to the circuit, the positive side and the ground side. We'll need to check them both. And to do that, you're going to need a voltmeter or multimeter similar to this one. Make sure that your leads are in the correct jacks to measure voltage, and then set your meter to the voltage scale. Connect the meter's negative lead to the B+ terminal of the alternator. Connect to the terminal and not the cable connector to test the complete circuit path. With the engine running, touch the positive post of the battery with your positive meter lead. Any reading more than a few tenths of a volt could indicate a problem somewhere in the circuit path. Look for loose connections, corrosion, or worn connector terminals as a possible cause. If the positive side tests okay, shut the engine down and attach your positive meter lead to the case of the alternator, anywhere you can get a good solid connection. Start the engine and move your negative meter lead to the negative battery post. Remember, if you measure any voltage more than just a few tenths, it's an indication that there's a problem in the ground path of the circuit. Ground side issues are the more common of the two. Consider that both the alternator and the starter, as we'll see in a moment, start off their ground path through their own casing, which is attached to the engine block. And from there, it has to make its way through another connection to a cable, and then finally back to the battery. Testing the starter motor is similar to the method that we used in testing the alternator. Now keep in mind that we can't measure voltage drop unless current is flowing through the circuit. That is, that the component that we're testing is turned on. So in the case of the starter, you may need to get some help from another tech to operate the starter as you perform the test. Or you can use the min-max function on the meter to record the test results as you operate it yourself. I also want to make sure that you understand to disable the fuel system prior to performing this test, so the engine will not start while we're taking our measurements. First, the positive side of the starter circuit. Connect your negative meter lead to the post where the battery cable connects to the starter. Connect the positive meter lead to the positive post on the battery and have your assistant attempt to start the engine. The starter motor circuit draws a lot of current, so I don't think I'd lose too much sleep if I saw anything less than 1.0 volts when taking this measurement. So now let's move on to the ground side. Here there are a lot more chances for problems only because of the long path current has to take to get back to the battery. Consider the starter motor is connected to the engine block. The engine block is connected to a cable which is then connected to the negative battery post. So a lot of places that voltage drop can occur, including misposition or improper installation of the starter motor itself. Attach the negative meter lead to the negative battery post. Either hold or attach the positive meter lead to the starter case and have an assistant attempt to start the engine. Again, any reading over 1.0 volts here needs to be isolated and corrected to ensure the circuit is in healthy condition. Verifying the condition of the electrical circuit is critical for a few reasons. Number one, we want to make sure that we're not replacing a component that isn't bad. And if we do prove the component to be failed, we want to make sure that the new replacement component has a fighting chance of working the way it's supposed to. And if you verified that the starter or alternator is indeed bad, make sure that you replace it with a quality, dependable component like those offered by Duralast. Duralast alternators and starters are triple tested and remanufactured by Tier 1 manufacturers, not just rebuilt. That means all components, subassembly and end units are tested and replaced with new wear components. And if you're looking to offer your customer a completely new unit, the Duralast Gold line offers 100% new starters and alternators. Both Duralast lines are engineered and tested to meet or exceed OE specifications for form, fit, and function, including amperage or torque output. And if a known defect is present in the OE design, Duralast engineers address that defect so you and your customer won't have to. They also come backed by a full nationwide warranty, including roadside assistance. Follow the tips that I've shared with you today, and if a replacement component is necessary, be sure to select one that's a dependable OE level component like those offered by Duralast. Then you can return the vehicle to your customer confident in a job well done. Thanks for watching.